Yeah, good morning and welcome to our talk on a remote interface for live interaction with OMNeT. I'm here together with my colleague Florian. We're both from Hamburg. And we come both from the field of wireless sensor networks, and that's what we use OMNeT for. And so to get into a motivation, we worked on an implementation of the IEEE standard 802.15.4 deterministic and synchronous multi-channel extension, DSME. Has anyone heard of DSME before today? Actually, someone. Okay, that's good. So just to be brief, it's not really important to this talk, but just to give you like our motivation, it is a data link layer protocol, and it introduces time-slotted TDMA communication to a multi-hop mesh network. So that's the idea behind it. There's a standard. Maybe more of you are familiar with TSCH, which is kind of a sibling of DSME, also from the 802.15.4 standard. And yeah, as I said, DSME promises wireless multi-hop communication without collision, so reliable. And we worked on an implementation of this with a colleague of us for quite some time. We also presented it, for example, at the Fachgespräche Sensor-Netze, and we had a demonstration at the Netzes, and we've got some analytical considerations as well. So if you're interested, take a look. But what we also wanted really to do is present our work in form of a demo, because we feel like that's a way to interactively introduce people to this protocol, and this might be applicable for models and other parts that you do in OMNeT as well. So we wanted to show, okay, how is the dynamic behavior of our protocol? What if you change a parameter? How does it change? And the demo seemed really suitable for us. And well, that's our OMNeT simulation, or one of them, a screenshot. And what we quickly felt was like that OMNeT is not really, for us, a sufficient tool for interactive demonstrations. And I will kind of start with a bit of a bold claim. The OMNeT UI is made for developing and not presenting. And I mean, obviously OMNeT is a simulator, so of course it's primarily made for simulating, but what I mean by development is you develop your models, you develop protocols, for example, and then you evaluate them, you simulate them, and that's what I feel the main focus of the OMNeT GUI is on as well. So what you can do is you can dig very deeply into your simulation at runtime. You can look at every module, at every parameter. That's really useful for debugging, for example. But it's somehow prohibitive for interaction with someone who's not that familiar with your implementation. And something else is OMNeT has very deep menu trees. So you can, for example, create very nice graphics with OMNeT from data collected at runtime. But it's a bit complicated to do so on the fly. And also one restriction is that the OMNeT UI is attached to one single simulation. I will get into a bit more detail on that point as well. So one OMNeT GUI, one simulation running. And so what we figured out is, since OMNeT is not really designed for demonstrations, and since there's also the limitation that we can't easily aggregate data from multiple simulations or multiple sources into one presentation, we have to do something a bit differently. And we went a step back and looked at what we actually wanted to do. So there might be additional requirements for other kinds of demonstrations, but what we wanted to do, since we were developing data link layer protocols, is we wanted to have a demonstration where we, the owner of this demonstration, can prepare something, and then someone else, you, the visitor, can have a look at it and interact with it. And what we wanted to do, for example, is we want to select some interesting sets of data that are generated live on the fly and present them in a way that someone else who's not familiar with our tools and our protocol can easily understand what's happening. So view events and view results as they're generated. Second part is one example of something you can interact with is the topology of the network you're currently simulating. That's actually more complex than most other parameters because it's not just a value you're changing, but there are a lot of design space in choosing your topology. But in general, one thing we thought about is that the presenter, the owner of the simulation and demonstration, can select some different topologies. So, for example, we use concentric circles for a lot of simulations because that's very close to one application that we thought DSME might be usable for solar tower power plants. So we've gone topology that's very typical for us. But there are other topologies. You might have a random distribution, or you might even want to introduce some mobility for traffic or something. So we wanted to have some support for this. And then the visitor is supposed to view the topology at least, so that he has an understanding of what's happening, and also manipulate the topology. So maybe choose from predefined topologies or reposition individual nodes on the fly. And more general, we wanted to have the possibility to select a set of parameters and manipulate them. So you can select, for example, for us, we do data collection scenarios a lot. Devices in the network generate data, forward it towards the sink, and what you can change there is how much data is coming. And that is one parameter that just requires some kind of slider, for example, where you can change and modify this value, and then you're supposed to get some feedback on how this impacted your simulation. And yeah, that was the basic idea behind. And additionally to this, there are some other requirements that we came up with. So I feel like it's very good for a demonstration if you can compare data from multiple sources. Because if you have developed some kind of a new model or some kind of a new protocol, it is very hard for someone coming from a bit of a different field and you give him numbers to see whether that's good, bad, what that actually means. But if you have some state-of-the-art protocol that's well known next to it, and then you can observe the dynamic behavior of both of them, that can really help a lot with understanding. And so what we figured is we wanted to have the possibility to merge data from multiple simulations. And what we ended up with even goes a bit further. So we heard a talk about devices under test from the automotive industry yesterday. And something that would be nice as well is maybe to not just merge data from simulations, but also have one part of your demonstration coming from a hardware device under test, and merging that all into some kind of consistent presentation. And something that would be nice as well is to separate the demonstration physically from the device that's doing the calculation simulation. Because for small simulations, and if you want to use real time, you can maybe do this and have some computation power free to run multiple simulations on one device and present them. But for larger simulations, it would be nice to outsource them to some kind of cluster and then view the results somewhere entirely different, or on a tablet or a phone, for example. So that was something we wanted to do. Now, we implemented this because we wanted to present it at the NetSys. So on the right, you see a small window of a demonstration, what we figured it might look like in the end, and what it does look like in the end. This is just an example. Outside, we have got a much bigger one you can interact with and look at after this session. And what we had in the beginning is a front end. We used, in this case, web technologies, so HTML, JavaScript, CSS, because it's very easy to do prototyping with it and to change the design and so on. And of course, in demonstrations, design is also an important factor. And on the other hand, we had a set of OMNeT simulations. In our case, it's, for example, a simulation for our protocol, DSME, and a simulation for another protocol for plane carrier sense multiple access. And in these simulations, we have got a lot of different modules. We have picked out the mobility module here and a traffic generation module. And traffic in this case, of course, does not mean traffic from automotive, but we mean data traffic generation. And in each of the simulations, we have got a lot of these modules because every device, every node in the simulation has one mobility module, one traffic module, and so on. And then the next step to combining our remote interface and the OMNeT simulations, and our approach was to use the web application messaging protocol, or short WAMP. So we integrated a WAMP server into the OMNeT simulation. And this is basically a new module that's running in the background in every simulation, and to record our results that we wanted to publish in the demonstration. So events in this case are recorded in some kind of result recorder. We called it live recorder because it's live, sending it then to the interface. So now we have got these two parts, and through this web application messaging protocol, they can be connected. And the web application messaging protocol has two different types of communication you can use in them in general. One is remote procedure calls, RPC, and we use this to manipulate the OMNeT simulation from the UI. So whenever, for example, in this case, I take a node and move it somewhere else, just drag and drop it, this will cause a remote procedure call. And then somewhere in the mobility module, there's a callback defined for this remote procedure call, and that will update the node position. So what we've actually done is each of these modules that is controlled from the front end has some logic built in to take remote procedure calls and do something. So the other example would be the traffic module. There's some kind of variable in there that determines how much traffic each node generates. And when we move this slider on the GUI and change the interval between packets, then these traffic modules have hard-coded information in them that determines what happens when we set this value. So we're not currently using these OMNeT parameters for this, for example, which would be a more generic approach, but in this case, we have got the logic really in the modules. And the other way, when we want to get data from the simulation back to our front end, or from different simulations, we use publish subscribe. So the WAMP server offers a connection for WebSockets. I should mention this probably, that the communication in between is done via WebSockets. And the front end, or every module of the front end itself, subscribes to a certain event in the simulation, and in this case in two simulations. So our traffic statistics module in the top, when we launch this GUI, it subscribes to the traffic statistics event from simulation 1 and from simulation 2. And the same goes for these node statistics that are a bit more detailed. And now every time an event is generated, or for example every second, which is how we do it currently, an event occurs here in the live recorder, and that gets published to the GUI, or to multiple GUIs. So you can have N-to-M connections between. So you can have multiple GUIs connected to one simulation and the other way around. Yeah, and this is a bigger shot of what we ended up with. Some of these modules, or I think all of these modules, are part of the demonstration out there as well. We've got some extra ones. Yeah, just to maybe show one a bit in detail, what we wanted to demonstrate here is over time, this is a time axis and new data comes in from the right. We wanted to show, okay, what happened in the network regarding end-to-end packet reception. So the green bar represents packets that arrived during the last second, and the red bar represents packets that were lost somewhere in the network in the last second. And this is, in this case, done by publishing an event every second in the live recorder that gets represented in the GUI. Okay. So to iterate what we contributed, we had the idea to design and design a framework for exchanging data between OMNeT simulations and front ends. And what we ended up with also allows us sending data from not OMNeT simulations, but for example, hardware devices under test as well. We use existing protocols. In this case, the backbone is done by the web application messaging protocol, which has the big advantage that there is an implementation for the major programming languages. So there's an implementation for GUIs in JavaScript, but there are also implementations for C++ and other languages, which made it easy to integrate it into OMNeT. And it's not such a complex protocol that you couldn't implement it yourself. So, and what we reach with this is we have a way to build modular UIs based on, for example, web technology. If you have something where you really want to show a lot of data and a lot of events, maybe JavaScript is not performing well enough for you, you can also choose to build a Qt UI remotely based on this. And what is different to the default OMNeT UI is that we can really select a couple of interesting features, data, interaction possibilities, and give them to a user who is maybe not as familiar with the protocol or the model as you are. So this is made for demonstrations. It's all open source. In this case, if you want to reproduce our demonstration outside, you need code from 2 repositories. One is our OMNeT DSME repository, where basically the DSME part and the server part in OMNeT is implemented. And in the OPP Live repository, we have all the code for the UI, which is not too complicated. And yeah, I deliberately limited this talk so we can have a bit of a discussion now, because one thing the reviewers noted when we sent this into this community summit is what we have done is not really specific to OMNeT. This could be done for NS3 as well, and for any other kind of software. And that is actually true. So right now, it is a very generic approach. We used it for OMNeT because that is what we wanted to use for our simulations, and it worked very well. But something that we could really, or something that we might want to do is move a lot of this functionality into OMNeT itself. Because currently what we have is we have got a lot of modules inside of OMNeT that we're using as part of our simulations and some kind of front end at the top. And every one of these modules is basically implementing some logic for taking remote procedure calls, or we have these special result recorders and so on. And in some ways, a much nicer approach would be to integrate support for this somewhere a bit further back. So maybe in modules in the OMNeT framework, or maybe into OMNeT itself. So that would lose a lot of redundancy from the modules itself, which would be nice. And then the way to do this would be to introduce a more generic way to record results and to change parameters. Because parameter manipulation right now is really, as I told you, handled by every module itself. It changes maybe some variable or performs an action or something. But I think since OMNeT has this abstraction of parameters, it would be nice to go to this level and introduce a possibility to really manipulate anything from the remote interface. And what I want to discuss with you now is basically, you can of course ask me questions regarding this, but our question is mainly, is this interesting for you? Would you like to have like an interface that you can use for demonstrations, for example, or to aggregate data and inspect dynamic behavior of your systems? Yeah.
First of all, give a big hand of applause for Maximilian. I'm going to start with the discussion. Just a basic comment. I think next to the presentations or demonstrations at the conference, this is also a perfect way to interact with students during classroom session. I've been using OMNeT simulations for some courses, and it's usually when for example, overload situations of TCP, you try to demonstrate, okay, fallback scenarios, stuff like this. And when somebody asks something and, oh, yeah, I'm just going to restart the simulation with some new parameter setups, wait until it starts up, go to the timeline again, everything. So this might be an even nicer way of demonstrating certain effects for a scenario. Of course, you have to pre-think about what you want to demonstrate and how, but
I have not even thought about this, because we don't teach much courses on protocols, and we don't. I think the other institute from our university who are also here.
But I guess for the majority of people that use OMNeT in classrooms, this might be also a nice way, but not from me. Questions from the audience. So maybe questions from the core team, comments, remarks, usability, is this nice thing?
Okay, the question that whether you have considered using LabVIEW, because like LabVIEW is commercial software, it's huge. And the part of its functionality is to assemble dashboards with full of graphs, displays, buttons, knobs, stuff like that. And if I'm right, it also has some kind of protocol to talk to it via the network. So it could also be possible, perhaps, to build into the simulation some kind of server which can connect to a LabVIEW front end.
Yeah. Okay, you're right. I'm myself not very familiar with LabVIEW, I have to say. Do you want to comment on this?
Yes.
Okay.
Because the Andres mentioned about LabVIEW.
Okay.
I'm just trying to be silent, but Yes, I briefly mentioned about it because about 20 years ago I was working at the Bell Lab, and one of my job was to use create the GUI interface for some of the testing system using LabVIEW, and then spent several months. Maybe that was 20 years ago, so maybe changed much right now. But the huge, how can I say, the delay and latency issues, and then process license, blah, blah. So we actually ended with the TK interface, much like OMNeT++. So I'm not sure, it's maybe 20 years after right now, maybe LabVIEW has much changed, but I do not have, I'm not very happy with any commercial kind of the software in this case, but actually I have a specific comment and question. First of all, I'm really, really excited to see this kind of initiative. And I already thinking about this kind of web interface on top of the command line, TK or Qt, whatever. Yeah. Especially related with the tutorial yesterday. Mm-hmm. One good example is IPython or Jupyter notebook. Yeah. It's definitely because this notebook framework is very flexible enough. There are lots and lots of other languages actually integrate into Jupyter notebook. For example, Julia, another very popular scientific programming language is created by MIT, also can use Jupyter notebook. So there's one example. But in this regard, I have one specification. Rather than just creating something totally new, by my understanding is that OMNeT++ already provides some modular approaches on top of the command line or TK, but we can also implement this web interface without changing much layout or whatever. But at initial step, maybe you can replicate a nearly similar TK interface, but through the kind of the web or this kind of connection. Especially I personally see the huge need for remote demonstration animation. As you mentioned, that actual simulations running in the deep cluster or AWS or cloud computing, but at home or maybe the meeting with the customer, you want to show the actual simulation animation, something like that. But in this regard, web technology, I think there may be some overhead for animation.
Yeah,
I'm not sure because there's no demonstration at all, but there's lots of animation. The amount of traffic exchange between OMNeT and the web browser would be huge. In this regard, I would recommend you to check the IPython notebook. They are using proprietary technology, 0MQ.
Okay.
Yeah, 0MQ is, I think, is a replacement of this maybe TCP whatever socket to make it efficient communication between the two. Yeah. But I really appreciated your initiative.
Yeah, to comment on this, the only thing we currently animate is, for example, the charts. So you can't see this on our slides, of course, because it's static, but you can have a look outside. We do some animation, for example, so it looks nice. And that is done client-side only in JavaScript. So there's no communication overhead for this. But if you wanted to do some animation based on, for example, node positions or vehicular networks where you animate some cars on a map, which would be possible with this as well, I agree that if you use web technology to display it as well, it might be a bit difficult with the overhead. Yeah. Just in a short distance, maybe. Yeah. Okay.
Just a comment on this. Since we use a WebSocket on the lower layer, we actually don't have this very high overhead. So, yeah. So this WAMP is already quite compressing the data. It's not like you have to send whole HTML pages or something, or JSON or something. It's already quite compressed. So it could certainly be better, but it's already quite good.
Okay, so first of all, thank you for this contribution. I think it's really useful. And I see a lot of potential, not only for the point of view of demonstration, but I see a lot of things that can be used also for simulation automation, from my point of view, at least. Because one of the possible applications is not rather just to showcase your result to someone else, but let's suppose that I run a lot of simulation. I would like to control whether they are going where I expect to. So maybe the confidence intervals are converging, or maybe I'm finding some strange behavior. So do you think it would be possible to also add some kind of simulation controls to this, like stopping deciding to stop the simulation, or on the other hand, the controls on the statistical soundness of the results, stuff like that?
With our approach at the moment, we have, for example, implemented resetting simulations with this interface. And of course, instead of using a web browser UI, you can also use some kind of scripting to control the simulations remotely again. But I think it's really interesting that this comment has come up, because we talked to the OMNeT developer team before, and they are actually also, or have thought and implemented something in regard of web-based control and really replicating the OMNeT UI to a remote place, right? So
It is somehow also connected to the presentation from Attila. So
Yeah.
in the general framework or controlling, distributing, and remote simulation in general.
with our current approach, I think it is, if you really want to have the full control over the simulation, this is currently not possible with the way we implement it, because every module itself has to, as I said, have implemented some remote procedures, for example. But if you generalize this approach and move it into OMNeT, and with a general way to access controls, then it certainly can be possible to monitor, for example, cloud-based infrastructure with this.
Okay, another just a very small comment. You mentioned that you can also control some of the parameters.
Yes.
Did you think about the consistency that is related to the modification of this parameter, or is just left to the developer? So what about if you modify a parameter and this happens in the middle of some kind of operation?
Yeah, that is very dangerous.
Okay.
For the DSME protocol we use,
Pardon?
since the DSME protocol we use and demonstrated is a TDMA protocol, and so it uses reserved time slots. And so this really doesn't like you moving nodes. And this is one example of something that creates inconsistencies, of course. That I think you will have to deal with this in your protocol, or it will show you that your protocol can't deal with it. And same goes for other parameters.
Time warp and
Yeah. I mean,
Okay.
for some things like timing related, for example, I think it's a bad idea to change some of these things at runtime anyway. So.
Okay, thank you.
Thank you. Just a short comment off topic about LabVIEW. So I've been developing LabVIEW for the last 2 years, and it hasn't changed a lot. so GUI development, maybe for a small measurement environment might be nice. For teaching purposes, it's very convenient. But like in an industrial environment, we had a climate chamber where we had over 250 nodes testing for over 1,000 hours with a lot of data throughput, a lot of measurements. And we used the LabVIEW GUI and had the software architecture built around it. And yeah, like Joseph pointed out, the latencies are not as good as they could be, and I'm not sure if we would redesign the system now that we would go with that. But for demonstration purposes, it's like a quick and dirty solution, and gets you results. So our physicists often use it to interact with measurement devices and so on, because it's easy to use, and just.
Plus, it's also quite expensive. So I'm not sure if every university has like free license of LabVIEW. So, but I guess we can agree that taking this approach to a generalized way and then integrating some web interface might be a good idea for future OMNeT versions. Just to have the flexibility of, you want to do this? Okay, there are some OMNeT modules, and another.
That it might be a more preferable way to go, because we're also thinking about going like
A decentralized way where we say, okay, with an HTML script or so, that you can sort of, that might be more the way to go than have like a centralized GUI approach with LabVIEW or something. So that you can call it up from any user.
Okay, so I guess we can still ask more questions during the demonstration afterwards.
Yeah, of course.
So let's
Okay.
give another big round of applause.
Thank you.